All right, in today's lesson here, we're going to talk about creating linear equations from a given word problem here. So let's take a look here and try to go through some of these. So you're going to get a bunch of word problems, and we want to create equations to represent these linear word problems and then solve questions relating to them. So take a look at the first question here. We have the cost of 7 dance lessons comes to $82. And it turns out that for 11 lessons, you're going to pay $122. So they want you to write an equation using C and L to represent this. So I'm going to let C equal the cost for dance lessons. And I'm going to let L equal the number of lessons that we decided to do. So if I want to write this question here, the first thing to observe here is, since we're creating linear equations, we know that the equation would be your rate of change times your number of dance lessons plus your initial value. So I'm really interested in finding my M and my B value. The B value in this case represents what do they charge you just to sign up for dance lessons, if anything at all. And then the M value is the cost per lesson. And I don't know either of those. So what I want to do here is I want to go ahead and take a look at 7 dance lessons equaling $82. I can represent that as a point. And as a point, that would be for 7 dance lessons, I'm going to pay $82. And then likewise for this expression here, I'm going to get another point. And that other point is for 11 dance lessons, I'm going to pay $122. So 11 dance lessons, $122. So now what I've done here is I have 2 points on my linear relationship. So what you can do here is you can label this first point, let's say x1, y1. I can label this x2, y2. And I can go ahead and calculate the slope, right? Given 2 points, you can do your change in y over change in x to get your slope of your line. So I'm going to do 122 minus 82 over x2 minus x1, and that's going to be 40 over 4, which is 10. So that means the cost, this is a rate of change, and this is the cost per dance lesson. So it's going to be $10 per dance lesson. So now I know that my equation is C equals 10L plus, I still don't know the initial value. The initial value is clearly not going to be equal to 0, because if the initial value was 0, if the dance lessons are $10 each, this price should have came to $70, not $82. So you can quickly see I can pick one of these points and sub in and solve. So in this case here, I can sub in my cost of $82, and that's for 7 dance lessons. And I can kind of unravel this to find my B value, which we already know is 12. But sometimes the math isn't quite as straightforward. Numbers aren't as clean. At any rate, your B value or your initial value is 12. So putting this all together, the equation is going to be C equals 10L plus 12 to represent the cost of these dance lessons. You're paying $10 per dance lesson and a base fee of $12 no matter what. So using that equation, we can now answer the next question. They're asking us in the next part, well, okay, how much is it going to cost for 4 lessons? Well, for 4 lessons, you're going to pay $10 per lesson plus a base fee of $12, and that's going to be a $52 charge for these 4 lessons. All right, let's take a look at another example. So the next example here, we have 76 degrees Fahrenheit at a 6,000 foot level of a mountain. And if you're at 12,000 foot level of this mountain, the temperature is 49 degrees Fahrenheit. Again, they want you to write an equation to represent the elevation and the temperature. So I know that when I am 6,000 feet of elevation of this mountain, the temperature up there is 76 degrees Fahrenheit. And I know at double that distance, so 12,000 feet Fahrenheit, the temperature drops down to 49 degrees Fahrenheit. So to create an equation here, it's the same idea. They did not give me the rate of change. I have to find this rate of change here. Now, if I read the question a little carefully here, it says, find the temperature T of elevation when you're E feet in thousands. So they want you to label this in a way that your E is on your x-axis and T is on your time. So my rate of change is going to be my temperature. So in this case here, the rate of change will be degrees Fahrenheit over feet. So per foot, my rate of change is how much is the temperature decreasing per foot that I increase my angle of my elevation up this mountain. So again, I found my 2 points here. And notice because when they define this here, it's referencing your E as on your x-axis. We're going to go ahead and label this x1, y1, x2, y2. And the slope of this is going to be y2 minus y1 over x2 minus x1. And if we do our math in this, we get negative 27 in the top and 6,000 in the bottom. And if I divide this out here, I end up getting negative 0.0045. And that's going to be your rate of change for this question. So taking a look at this problem here, we see that the temperature of the mountain is going to hit a rate of change of negative 0.0045 E plus, once again, I do not know the base of the mountain here. So I have to go ahead and substitute this in to find the sort of initial value where this started. So I'm going to go ahead and sub one of these points in here. If I sub one of these points in here, we end up getting the following. I'm going to sub in my first point. I get 76 is negative 0.0045 times 6,000 plus B. Solving for B here, I get B equals 76 plus 0.0045 times 6,000, and the B value comes out to be 103. So the equation to this question, and this is what we're looking to create here, is the temperature is negative 0.0045 E plus 103. So continuing this question here, we want to know is at 20,000 feet or elevation, I should say, up the mountain, what would the temperature be? Well, my temperature is going to be negative 0.0045. Get rid of that E and change it to 20,000 and add your sort of base temperature and calculate this. And this comes out to be 13 degrees Fahrenheit. So you can see at the 20,000 degree level, it is very cold. All right, let's take a look at one more. So for the next problem here, we know that between 1990 and 1991, the number of movie screens in the United States increased by 1,500 each year. And then in 1996, there were 29,690 movie screens. They ask us to write an equation to represent the slope and y-intercept for this. And you're going to let y equal the number of movie screens. And we're going to let x equal a given year that they sort of quote here. So notice in this question right away, they gave us the rate of change. I know that the rate of change is 1,500 movie screens per year. Between 1990 and 1999, we've got 1,500 more movie screens each year by about that amount. Now, what do they give us here? If I go to my equation, I know my equation is y equals m x plus b. I've got my m value. Here they gave us an actual point. Now, what is this point going to be? If you express this point, since when time is 0, in this case here, when x is 0, that represents 1999. If I want to continue this here, this point here is going to represent, if it's 1996, this will be 6. And when x is 6, so 6 years have expired, the total number of movie screens is 29,690. So now I've got myself a slope. as you see here. And then I have a point. So I'm going to sub the point into the equation here. So this becomes 29,690 equals 1,500 times 6 plus b. And I end up getting here 29,690 equals 9,000 plus b. So my b value here comes out to be 20,690. So that represents the initial number of movie screens. So the equation here becomes y equals 1,500 x plus 20,690 movie screens. So we have our equation to represent number of movie screens. Continuing this up here, they just say, okay, what's going to happen in 2005? If I let t equals 0 represents 1990, if we go to 2005, you can see here t is going to end up being 15 years. So in this equation, the equation becomes 1,500 times 15 plus that base equation, or base number of movie screens, and the estimated number of movie screens comes out to be 43,190 movie screens. All right. Okay, that concludes today's lesson. Just going through some examples of linear relationships, word problems with linear relationships, where you create your equation and solve certain questions regarding them. So you can see here this was sort of like a given 2 points, how to find the equation of line version of a word problem. This here was as well, and then this ended up being, they gave you a slope and a point. And for some questions, even easier ones, they just give you the rate of change and the initial value straight away. You just sub it into your formula. All right, thank you.